Hello everyone, I'm Dr. Tejashwini N. Welcome to my YouTube channel Study with Tej. Today we shall discuss on network types. Network types are distinguished by criteria like size, geographical coverage, and ownership. LAN, local area network. It is a computer network that interconnects the computers or the devices within the limited area, for example, school, lab, office, or home. So a LAN can be a small or a large, ranging from home network with one user to an enterprise of network with thousands of users and devices in the office or school. LANs are capable of transmitting the data at the fast rate in the limited distance. If you can see here, there are many connecting devices like switch, router, and also many other devices like laptop, desktop, printers, all those things. So basically, the LAN is privately owned network that connects some host in a single office, building, or a campus. Each host in a LAN has a identifier that uniquely defines the host in the LAN. A packet sent by the host to another host carries both the source and the destination address. Switches recognizes the destination address of the packet and guide the packet to its destination without sending it to the other host. It also allows more than one pair of communication with each other at the same time if there is no common source or destination. And LAN can be of two types, wired and wireless. If it is wired, obviously example is Ethernet, and if it is wireless, it is Wi-Fi. Coming to wide area network. So wide area network is with large geographical area, and here many LANs might be connected together to make a WAN. The geographical area might be from town, state, country, and even world as well. It connects devices like switches, routers, or modems, and WAN is created and run by the communication. Let's see and two examples of WAN today. That is, one is point-to-point WAN and switched WAN. Point-to-point WAN is a network that connects two communicating devices through the transmission media. If you can see here, two systems are connected through the transmission media. And switched WAN is a network with more than two ends. It is a combination of several point-to-point WAN that are connected by switches. If you can see here, many combination of point to point, and you have many end systems also. It is not like only it should be between two nodes. It can be between more than two ends, and it is connected by combination of several point to point WANs. So this is switched WAN. Next is internetwork. Today, it is actually difficult to see a LAN or a WAN alone. So, internet work or internet is a connection of two or more such networks. So, if you see the figure here, there is one LAN here and one more LAN here, and office of two different branches. Here, this is a West Coast office, and here is the East Coast office. And suppose a system here wants to send an information to system here, then it routes through router, and from here there's a point to point WAN, and it comes to this router. From here it gets routed to that particular destination address. If in case the system from this end has to pass in information to system in the same office, then it doesn't go to R1. Instead it gets routed here itself using the switch. So that is a difference. So same thing with this as well. If it is within this, it doesn't go to router. Instead, within the switch here itself, it shall send the message or the information. So this is the example of two branches of a same office. Okay. Then this here, if you can see, there is this is an example or a diagram of heterogeneous network made out of four WANs and three LANs. If you can see, there is one switched WAN here and point-to-point WAN here. This is one single resident that has been connected to point-to-point, and lots of WANs there, and again point-to-point here from router to router, and this is a regular LAN, and land here again a point to point WAN. So one, two, three, four are the four WANs here and three LANs. This is one LAN, second LAN, and this alone is considered as one LAN. Even a single system which is connected to the internet can be considered as a LAN. So this is how it is. Then let us look into what switching is. So basically, switching is a process of transferring the data between two devices in the computer network by selecting the best route for data transmission. Internet is basically a switched network in which a switch connects at least two links together. Two most common types of switched networks are circuit switch network and packet switch network. And the switching consists of interlinked nodes called switches. So the switch might be an hardware or a software device that is capable of creating the temporary connection between these two devices. So now let us see what a circuit switched network is. So this is a dedicated connection called a circuit is always available between two end systems. The switch can only make it active or inactive. It is a complete end-to-end path that exists before the communication can take place. It was just like the how telephone works. And circuit switching basically happens at the physical layer. There are three phases of circuit switching. One is connection establishment, data transfer, and connection disconnect or termination. So these things we have to think of. The capacity here, the switch don't store anything; they just forward the data. The capacity of the the capacity of the line, whatever the highest capacity, is not fully used at all the time. Even though it has been dedicatedly given to the two end systems, it is not effectively used. It's efficiently used at its full capacity only when all the telephone at the end systems which has been communicating all works at the same time. Then probably the whole link efficiency is used. If not, it goes in vain. So this is how the circuit switching looks like. So you can see there is a dedicated link. There is one dark line. If you can see the mouse moving from this device to this device, already and path is being established. So many paths are possible, but only one path is selected as per the call. And this circuit stays active even if no one is sending the data or messages, or no one is speaking. Once the call has been established, all the communication shall take place in this path only, or the path of the circuit, whatever you can call it as. And the circuit is dedicated to this call for that particular duration of the call. So this is all about circuit switching. And properties of circuit switching are its efficiency. If the data is not, I mean, if it is not to the full extent of the link capacity, then the capacity of the channel is being wasted at that duration of connection. Then delay, especially the circuit establishment and termination, it is a waste of time wherein there is no data transfer shall not happen. So that is the delay here. And low data delay after the circuit establishment, the information is transmitted at the fixed rate. So there is no data delay there. That is less. So it is mainly developed for voice services. Next, coming to packet switched network. So here, smallest units of data called packets are routed through the network based on the destination address contained in each packet. The internet, instead of continuous communication, blocks of data called packets are communicated between two ends. Here, the switch functions both as storing and forwarding device. A router in the packet switch network has a queue that can store and forward the packet. If the packets arrive at the router when the thick line has been already working at its full capacity, the packet should be stored and forwarded in the order they have arrived. So, therefore, packet switch network is more efficient than circuit switch network, but packets may have some delay. So each time the device sends a file to another, it breaks down into packet so that it can determine the most efficient route for sending the data across the network at that particular time. So, in packet switching, the no resource allocation will happen for the packet. That is just like in your circuit switch, the dedicated path that the whole resource is being dedicatedly given to those particular end system. That doesn't happen here. So, resource allocation will happen on demand, on spot, whenever there is a packet or a smallest unit of data that wants has to be transferred. Only at that particular time the resource has been allocated. So that is the difference between the circuit switching and packet switching. Next, coming to internet. Internet is also a wide area network, and this internet is worldwide system for interconnecting the computers and electronic devices or the gadgets that can communicate with each other using an established set of protocols. So there are many WAN, LAN across the world that are connected to each other, and process of transferring the information over the internet from one device to another relies on packet switching. The internet is a packet routing network that uses TCP and IP protocols for communication. And internet has a backbone, provider networks, and the consumer networks. At the top level, the backbones are large networks owned by some communication companies. The peering points are used to connect the backbone networks. The provider networks are smaller networks that uses the service of the backbone for paying the fees. The customer network, here in the diagram, if you can see, customer networks are the last one to use the services provided by the internet by paying the fees. You have to pay some fees and take the services that has been given by the internet service provider. Both the backbone and the provider networks are known as internet service providers. So, internet service provider are nothing but the backbone or the provider networks. Both are at local and regional level, national and regional ISPs. So they both act as the internet service provider. Next, coming to accessing the internet. To access the internet, the user has to be connected to internet service provider physically through point to point WAN. To do this, we can convert telephone lines to a point to point WAN by two ways. One is dial up services. This is adding a modem to the telephone line to connect data to voice. The software installed in the computer dials the internet service provider and initiates making a telephone connection. But the dial up services are very slow and the line cannot be used for telephone connection when it's used for internet connection. So both cannot be done simultaneously. Next, coming to DSL services. Here, the telephone line are provided with high speed internet service, and same line can be simultaneously used for voice and data communication. So here you can use both. Other means to connect are using cable networks. So, cable for TV broadcastings are upgraded for internet services as well. And another one was using the uh, wireless network. So, wireless WANs is very popular now. And direct connection to the internet, the large organization can itself become a local internet service provider, local ISP, by leasing a high speed WAN from the carrier provider and connects itself to the regional ISP. So this is how it is. Then uh, wireless network. So will have to talk about that as well. Wireless networks and cable networks. If you have seen at your home, you will be having a most of the time it is a coaxial cable that comes as a TV network. Using that also via TV, cable TV wires, that you can also have access to the internet, and it uses the broadband connection, and it is comparatively faster than both the dial-up and DSL, but it is only available where TV cable is available. That when if that network is already established, then you make use of it for internet as well. Then wireless is just it is 3G and 4G services are most commonly used with mobile phones, and it connects wirelessly through your internet service provider network. So these are the ways through which you can access the internet. Sorry. Thanks for watching. For informations on data communication and network, keep watching my channel. Thank you.